Hello and welcome back to the Linux Panic YouTube channel. This is video 4 on the Linux from scratch stable LFS version 11.2. Where we last left off in the last video, we just finished off compiling the temporary crystals, compiling the temperatures. As we can see here, we'd finished off with GCC, and we're now moving on to entering the true root environment. Now, so let's get this done correctly. Now, from 7.1 to 7.4, everything must be done as root. As it says here, until section 7.4, entering the true root environment, all commands must be run as root with the LFS variable set. So we must leave the LFS user that we've created and echo LFS. As we can see here, the LFS variable is set. First thing we need to do, the commands in the remainder of this book must be performed whilst logged in as root and no longer as user LFS. Also double check LFS is set in the root environment. So again, LFS is set. So now we have to change directories back from the LFS user to the root user, and we do that with copying the first line, entering that in, and now what we want to do is we want to change this, and that'll then change things around just to again confirm LFS user is set. Let's cd into sources. Well, do an lsla as we can see here. Cd LFS. All of these now belong to the root user again instead of the LFS user, which is good. Play the screen, and this is the point where we now need to go through and add more directories, which can be done in the following. Various files, existing file systems exported by the kernel are used to communicate to and from the kernel itself. These file systems are virtual, and that no disk space is used for them. So this is basically just aliases, because that's how it's handled. But as we all know, in Linux, even folders are files. Everything is a file. So we need to begin creating directories onto which file systems can be mounted. So once again, we want to echo LFS. So the LFS variable is set. It is important. We don't forget that. Want to do this, as we can see here, we have dev proc sys and run. These were made. That is correct. During normal boot, the kernel automatically mounts the dev temp file system on the dev directory. This allows the devices to be created dynamically. So it's just for device creation and temporary stuff during boot. So what we need to do is we need to mount -v bind dev to LFS dev. This can be done with that dev mounted on mount LFS dev. And we must mount the virtual kernel file systems, which we can do by copy paste. So that was dev pts. So proc sys and run, as we can see here. Bound, mounted, which is good. On some host systems, the dev shm is a symbolic link to run shm. The run temporary file system was mounted above. So in this case, only a directory needs to be created. So it's just as simple as copy and paste it in. We now need to move to entering in the true root environment. Now this is basically how we're going to be handling stuff inside of the operating system we're going to be creating. So when we execute this here, this is going to turn the environment we've just made into our root directory. And it's going to say, hey, look, I have no name. I can't do anything because we haven't given it a users file or a passwords file or a group file. We've not given it any of the identifying characteristics. As we can see here, we're now in the LFS root. And if we do s-la, we have all of the stuff here that we've just been working on and made. And as we can see, no name, but we're in the root, which is good. What we need to do is we need to create some root level directories as is required. Some directories mentioned in this section may have been created earlier on. but it'll be doing it again just for completeness, which is much better. So what was created was boot, home, mount, opt, and serve. Boot, home, mount, opt, and serve. We're going to copy all of these. We're not going to do them individually because it's going to be too much of a pain in the ass. So we created all of these extra directories. We're going to add that link into here. Add the link into here. So varlock is now runlock, and that is now set correctly. And we're going to do that. Followed by this. And now directories are by default created with 755. This is not desirable in the two commands above, so these two here. Two changes are made, one to the home directory of the user root, and another to the directory for the temporary files. What we now need to do is we need to create the mtab, which is basically a way of the kernel exposing itself, so it can then access the proc file system and then go through the processes there. So we just need to create that link, go in there. This is our hosts file, so every Linux system has it. It's just a way of networking, so that's put in. How it does it is it goes, make this, or keep an eye on this file. Anything that is from here down to EOF goes into here, and EOF just says enter file. So in order for the user root to be able to log in and for the name root to be recognized here, because bearing in mind this is saying I have no name until we give it one. In order for that to be recognized, we need to create a passwords file. In this case, it's going to create the user root. And as it says, the password will be created later on. We also need to create the groups. As we all know, every Linux operating system also has groups. This is a basic thing. As we need to, as I am just going to confirm, I am just going to make the screen a little bit bigger, just to make sure that it has not written over itself. Okay, so that is fine. There we go. I'm just going to do clear. Bring this back here. Ooh, probably not that big. And now, if we need to create the tester user. This is just going to be used for chapter 8. It's just for testing things that we install along the way, just to make sure it's going to work. Again, copy and paste it in correctly. Tester user is created. And now what we're doing here with the execute user bin bash plugin is it's going to refresh the shell, because we've gone through and made a lot of changes, and what we're doing is just refreshing it and logging into it, so it then knows what to do. So it's just execute, so it's execute user and bin bash, and just log into the shell. We now have the root user. This is good. And what we need to do is just initiate the log files, because if we don't initiate the log files, no login's going to take place. So we need to create the log files for this to start taking place. So it's just copy them, copy them. We did last log, and now we need to do btmp. And that's that done. So now these log files will record. And we need to go through and make some packages: gettext, bison, perl, python, texinfo, and util linux 2.38.1. So the first thing we need to do is get text. So because this is our directory, we don't need to worry about having to go cd into LFS, then go into the thing. Nope, it's all here. So we just need to do cd sources, and we need to tar-xvf get text. Wait for that to extract. Cd into get text. And this needs us to configure the configuration option of disabled shared. We do not need to install any shared libraries. That's going to go through. Going to make the configuration file. As we can see, there are no issues here. Last time around I did this, I ended up losing progress up to this point because I had made a mistake earlier on in the process and I couldn't figure out what it was. It's a compiler issue, but as we can see here, this is flying through. This is a rather large make file. Well, so something to be aware of as well. So once this is done, this has a standard build unit time of 1.6, so we're looking at just shy of 3 minutes roughly. So once this is done, we'll then have to move on to the next package, because bearing in mind, because we're inside the root user, we're in the Chroot directory, we're actually inside what will become the system. Anything we do here now will reflect in the system. So now that we've configured, it's just time make, and we will return once that has finished compiling. Okay, now that we have finished with the compilation of getText, what we need to do is we need to install the message format, message merge, and getText programs. So it's just as simple as copy this, come here, paste this in, hit enter. As we can see, that's done perfectly fine. So we just leave the directory, remove the directory, move on to the next one. In this case, it is Bison. It is a parser generator, so all we have to do is just tar-xvf Bison, cd into Bison, and then run the configuration. So what this is just saying, it tells the system to install the Bison documentation as a versioned dictionary. So that's simple as. Once that's done, it's just make it, install it, move on to the next part. So if you've made it this far, I'd like to say thank you very much for watching so far. I hope you're enjoying all of the videos at once. If you've made it this far into the video series, thank you. And tell me how long it's taken for you to get this point. To me, it's taken a few hours. This shouldn't take too long at all if you're doing it in one sitting. If you're not doing it in one sitting, that's also fine as well. Now we've configured Bison, we want to do time make and just wait for this to go through and compile. The reason why I'm not giving it compilation flags in the form of adding extra cores is because I don't wish to cause myself any problems in this part of the process, because it is again building additional tools that are needed for chapter 8. Now when it comes to doing chapter 8, it's gonna take significantly longer to do. Now that we've compiled it and we've installed it, we just leave the directory, remove the directory, and move on to Perl. It contains practical extraction and report language, I'm guessing that's what that stands for. And because this has the 1.6 standard build unit, it's a little bit longer, so we'll have a little bit of a gap, but that's not too much of a bother. So it's just tar-xvf Perl, and we'll cd into Perl, and have a look at what this is. Have a look at these configuration options. There's a lot of configuration options here. We're just going to paste it in, and now we'll return when it comes to install the package. Okay, now that we are back from making it, this does recommend we run the test suite, but we can't do that just yet because this is not time for it. It's chapter 8 where we need to run the test suite. So all we're going to do is we're just going to install Perl. That's going to go through the process of installing it in the correct place. And now all we have to do is Python, xinfo, and util Linux, and we're done. That's all we have left for chapter 7. So To leave the directory, remove the directory. Open up a new one. So tar-xvf Python. See, now this is important where you pay attention because there are two packages named Python. We want the one that is 3.10.6 .r. I say .r, the capital P. So it is important. We do pay much attention. So non-recoverable.tar.xz. It's important you pay attention to the file and the extensions. So cd into Python. Have a look at the compilation options. In this case, it's just saying enabled the installation of a static library, and the switch disables the Python package installer, which we don't need at the moment. So paste that in. That's going to go through the process. Some Python 3 modules can't be built now because the dependencies are not yet installed. The building system still attempts to build them, so the compilation of the files will some files will fail, and the compiler will indicate a fatal error. However, these can be ignored because the overall make command didn't fail. It was just optional modules are not needed right now. So now that we've done that, it's just make. Watch out for the hey look, there's an error, but we shall return once this is done. Okay, now that we have finished with the making of Python, all we have to do is just install it with make install. Simple make install. It's going to go through and install it in the correct place. As we can see here, it's doing a lot. So again, it is expected that there would be some errors because of the fact there are some modules that can't be made now, but that's fine. So we leave the directory, remove erect Python directory, move on to textinfo, which is just information for reading, writing, and converting info pages. It's 0.2 standard build unit, so it shouldn't take too long at all. What we want to do is we want to do tar-xvf textinfo. Help if we did not uppercase it when we didn't need to, so cd textinfo. Configure this with the prefix in the correct place. Once we've done that, it is a matter of making and then installing. Again, this is one of those scenarios where it's probably going to take longer to do the compilation of or setting up the make file than it is to actually compile and install it. So we are now approaching chapter 8. Chapter 8 is a very, very long chapter. So I'm not going to split it up into multiple videos. I'm just going to do it in one video. And there's going to be a lot of empty space in the video. So expect that for the chapter 8 video. Now that we have we've compiled textinfo, all we've got to do now is just make install it in the correct place. Now that we've done that, it's just leave the directory, remove the directory, textinfo, and move on to utility Linux. A util Linux package contains miscellaneous utility programs. That's fine. So we want to do tar-xvf util Linux, cd into util Linux. The file hierarchy standard recommends using the var library hw clock directory instead of the etc directory as the adjust time file. This can be created with the following. So just do that, as we can see, created. Prepare for the compilation with this rather long make file configurations. So here it's just adjust time path is now var lib hw clock adjust time. So we've set that up. It's finished faster than I thought it would be. So what you're going to do, make the lib directory equaling user lib switch ensures that the shared object symlinks targeting the shared library file in the same directory user lib directly. The disable one prevents these switches prevent warnings about building components that require packages not in LFS yet. Also, packages that aren't there yet can be dealt with a clean way. Without Python, the switch disables using Python. It avoids trying to build unneeded things, which is good. And the run stated directory, this switch states the location of the socket used by UUID, and libuid. So it's just making sure everything is as it should be in the correct manner. This also looks like it's disabling the login as well as the switching user and set private and run user, just disabling things that don't need to be there yet or at all. But all we have to do now is wait for this to finish going through the process, which it just has. We've made it, now it's just make install. This will fly through. Some warnings were expected, that's fine. So now we want to leave the directory, remove the directory, and move on to the next one. So this part is just cleaning up the temporary system we've made because we've gone through, filed the packages and all that. Now we can go through the process of removing things that we don't need from here. So the first thing we're going to do is we're going to clear our screen. We're going to remove documentation, which will save us about 35 megabytes worth of space. And second, the libtool.la files are only useful for linking with static libraries. These are not needed and could be harmful for dynamic shared libraries. So we'll remove them now. And the current size of the system is now 3 gig. However, the tools directory is no longer needed, so we can cut a gig of space out of that. So if we want to, now would be the option to back up the system and go through the process, but because we're not going to, we are now calling this video. We're now going to be moving on to chapter 8 next, which is all of these packages. So things could take a little bit longer, but that's the end of this video. If you liked the video, hit the like button. If you disliked the video, hit the dislike button. You may only be able to see 50% of the options, but I can see 100% of them. So that's always something worth keeping an eye on. But anyway, I've been Nick, you've been amazing, and I hope you have a good rest of your day. Goodbye.